My name is Daniel Kwan and this is BC Montgomery High School Math Tutoring Club. We're located in Torrance Boulevard, right next to Redondo Beach. Today we're going to talk about 1969 AP Calculus BC free multiple choice questions 1 through 5. Number 1 is the asymptote of the graph of the parametric equations x equal to 1 over t, y equal to t over t plus 1. So we have to find the asymptote. Before we start beginning, let's switch this to t equal to, for example, t equal to 1 over x by multiplying t to both sides and dividing x to both sides. So now we got the value of t by 1 over x. So let's plug t into y value. Y equals to t 1 over x over 1 over x plus 1. If we simplify this equation, then we will get 1 over x plus 1. And then everything's done. So, in the multiple choice, it is given that a given x equal to 0, y equal to 0, x 0 only, x equal to -1, y equal to 0, d x equal to -1 only, and e x equals to 0, y equals to 1. So, by looking at this, we can imagine. So, before we think about plus 1, let's just think x 1 over y equals 1 over x. The graph of this will be looking like something like this. And now, because it's plus 1, we move to the left one side, and it will become, if this was -1, it will become here, more like this, move to the left. So, we can see that the horizontal asymptote is 0. So equation will be y equals to 0, and the vertical asymptote will be right here, which is x equals to -1. And we can just see by looking at the equation, oh, when I plug in -1 to the x, then it equals to, or I mean, it is undefined, so it will be asymptote. And by looking at this, we can just imagine the graph. Oh, it looks like this, so horizontal will be 0. So what is x equals to -1 and y equals to 0? Right here. So the answer will be C for number 1. Number 2 says, what are the coordinates of the inflection points on the graph of y equal to x plus 1 times arctangent x? So, because we're solving for a point of inflection and only the y function is given, we have to solve for the second derivative of this function to get the point of inflection. So, we start by solving y prime. And by looking at this, we can just easily notice it is a product rule. So, x plus 1, and we derivatize this, so 1 over x squared plus 1, plus, now we derivatize this, so it will be x, no, it will be 1, sorry, and it will be our tangent again. And now, I will simplify a little bit more, x plus 1 over x squared plus 1, plus arc tangent x. This is so annoying, I can tell. And now it will be another second derivative and say this is quotient rule, so it will be x squared plus 1 squared over low del high, which is low stays the same, x plus 1 low del high, which is derivative high, so we times 1 minus, now opposite way, so this stays the same, x plus 1, and now we differentiate this, it will be 2x, and plus, again, this is so annoying, x squared plus 1. Now if we do this, it will become x squared plus 1 minus 2x squared plus 2, no, it's my mistake. Minus 2x, because minus goes in front, so, and because it's multiplication, over x squared plus 1 squared plus 1 over x squared plus 1. Now, we can put this by negative x squared minus 2x plus 1 over, we can write this as x squared plus 1 because it's squared, so it will be x to the 4th plus 1, it will be 2x squared plus 1 plus 1 over x squared plus 1. And to combine this, I can just do this by multiplying both sides by, top and bottom by x squared plus 1. I can just get x squared plus 1 over 4, this is so dirty. X to the 4th plus 2x squared plus 1. And lastly, it will be, so we combine this, so this cancels out, and 2x plus 2 over 4x, keep writing. X to the 4th plus 2x squared plus 1. And now, if we solve this, if we make this to equal to 0, because this we're solving for a point of inflection, we'll get. If I plug in 1, do you see? In a fraction, if you want to make it to 0, just look at the top, because if the bottom equals to 0, it is undefined. So just look at the top. So the top equation, I'll write it here, is negative 2x plus 2. And to make it equal to 0, I can just plug in 1 to make plus 2 will make 0, because 2 minus 2, or negative 2 plus 2 will be 0. So now we got the x coordinate for 1, so x equals to 1. So now we have to plug in 1 to this equation. So I'll erase the top part. So let's plug in 1 for here. So it'll be 1 plus 1 times arc tangent x, 1. And you know arc tangent is the opposite of tangent, so normally if I convert this to the normal equation, this will look like tangent x equals to 1. And when we look at this equation, let's think the unit circle. Oh, when tangent equals to pi over 4, it will be radical 2 over 2 over radical 2 over 2, which cancels out to 1. So arc tangent 1 will be radical 4, and this will be 2. So this will become 2 times pi over 4 equals to pi over 2. And in the equation, the answer is E, which is 1 pi over 2. Number 3 says, the mean value theorem guarantees the existence of a special point on the graph of y equal to radical x between 0 and 0 and 4 and 2. What are the coordinates of this point? So, before we start, let's write out the mean value theorem function. So, which is equals to FB minus FA over B minus A. And all the time B will be the greater number. So this time this is x coordinate, y coordinate, obviously x coordinate, y coordinate. And because B is 4, then this will be 2 minus 0, 0, so 0 over B 4 minus 0, 2 again. So FC is equal to 2 over 4, which will equal to 1 over 2. Now, because f prime c is 1 over 2, and because this function is f prime, let's solve for f prime. So it is given that y is equal to radical x, right? So if we differentiate this, y prime will equal to 1 over 2 radical x. And to solve for c, we can just put this equation here. So it will be 1 over 2 radical x equal to 2. And this is obvious because if we just plug in 1, it will become 1. And so that means x equal to 1, right? Now, because we have to solve for y value, we just need to plug this back into here and solve for y. So what is radical 1? It will be 1. So the coordinate will be 1 and 1. And when we look at the choice, the answer will be B. Number 4. Number 4 is the integration 0 to 8 dx over radical 1 plus x. So let's simplify this equation first. So step by step, it will be 1 plus x, right? And then it will become radical 1 plus x to the negative 1 because it's 1 over. And then lastly, this will become 1 plus x 1/2 negative 1. And again, if we do the multiplication, it will become 1 plus x to negative 1/2. And after we get this information, this function, we have to integrate this function. So, because it might look confusing, we can just put u as 1 plus x dx, 1 plus x, and du is equal to 1 dx. Now we can put this u as u negative 1/2. And this looks way, this looks way simpler, right? So let's integrate this. So by doing integration, we can just add 1 at the end, which is the top, the exponential. We can just add 1, it will become 1/2. So we bring that 1/2, so I'll write 1/2 right here. Bring this 1/2 to the front, so it will become 1/2. And when you're bringing this to the front, you have to reciprocate it. So it will be 2u 1/2. So if we want to check, we can differentiate this. So this 1/2 goes down 2, make it 1, so nothing goes here, and then minus 1, which will become negative 1/2. And now let's re-plug this in. Then this will become 2 radical 1 plus x. Now everything is left to just plug in this number. So let's start with 8. So this will be 0, 8. When we plug in 8, it will be 2, because 1 plus 8 is 9, 9, minus 0 will become 2 radical 1. Now, because radical 9 is 3, so we can say 6 minus 2, because 2 times 1 is 2, which will become 4. So, the answer for 4 is D. So the answer for this multiple choice question is D, which is 4. Number 5. Number 5 says, if 3x squared plus 2xy plus y squared equals to 2, then the value of dy dx at x equals to 1 is. So, by looking at the equation, 3x squared plus 2xy plus y squared equals to 2, we can easily notice this is differential equation, DQ in other words. So, first, because the given is x equals to 1, let's find the y value. So when we plug in x here, it will be 1 plus 2y plus y squared equals to 2. And this will be 3 plus 2y plus y squared equals to 2. And we can easily see that if we plug in negative 1, 3 to negative 1 plus negative 1 will be positive 1 equals to 2. It will be 3 minus 2 because negative 1 times 2 plus 1 equals to 2. And do you get it? It will become 1 plus 1. So the y value will be negative 1 to make this equation. Now it's turn to differentiate this equation by using differential equation. So it will be, if we differentiate this by dy dx, it will be 6x plus 2. Now this is another product rule. Stays still. Sorry. X y prime plus x goes away and y stays still because front back front plus 2y y prime equals to 0 because this is constant and it becomes 0. When we simplify this equation, it will be 2xy prime plus 2y plus 2y y prime equals to 0. And just to tell you, y prime is equal to dy dx only in this function. If it is dy dt, it will not work, but dy dx, it will work for y prime. So, because I know it will be annoying to write dy dx for every single base. So let's combine by y term and factor it out. So y prime is 2x plus 2y equal to, now we use this term and we use this term to factor it out, and 6x plus 2y has been left, so let's move this 2 term to the right side, which will become negative 6x minus 2y. To make it y prime equal to negative 6x minus 2y over 2x plus 2y. Now, we can just now plug in this given numbers to here. So, it'll be 1 and negative 1. However, you have to notice, look at the bottom. It's 2x plus 2y, right? I'll write here 2x plus 2y. In real test or during the test, you have to plug in every single thing to solve for the answer. However, this is now looking obvious because we have the number x equal to 1 and y equal to negative 1. And if we plug in x equal to 1 plus y equal to negative 1, negative 1, it will become 0, right? And then when 0 is at the denominator at the bottom, the answer is undefined. So this answer for number 5 will become undefined. which is E. Yes. Thank you for watching this video, and I hope this video was helpful.